Okay, we're going to look at low-level programming, assembly language, and how we use relative and absolute addressing in this programming language. Okay, so basically, what you've got to think about is that the fact that when you run a program, it is loaded into memory in order to be run. Okay, it has to go into the program's memory to be then transferred, each instruction to be transferred to the processor to then be processed. Okay, and the addressing really refers to the actual location of each instruction within memory. I'm going to look at the first example, which is using absolute. So this is, I'm going to change that color actually. Okay. So this is an example of absolute addressing here, and you see in this column these numbers are referring to memory locations. I've just randomly selected 200 to 210. There could be any numbers, and they just run in sequence because that is the way the program needs to be in order to run. Okay, so this program is loaded into the memory at beginning at position 200, location 200. It's 10 lines long, and therefore it occupies 200 through to 210. I said it's 10 lines long, it's actually 11. Okay, so the first instruction uses immediate addressing, and it loads the value 0 into the accumulator. The second stores the value at location 210, which is here. So this stores this 0 in 210. Then we load, again using immediate addressing, the value 42 into the accumulator. The out instruction, that takes the instruction and outputs whatever value there is in the accumulator as its ASCII character. We then load direct, so it's the value at this address location using direct addressing, the direct addressing mode. So we go to 210, we load the value 0 into the accumulator. We then increment the accumulator, so the value currently in the accumulator is 1, and we store it again using absolute addressing at memory location 210. So in fact this would now contain the value 1. That'll look more or less like a 1. Okay, then we compare that with the number 5. This is what this is here. This is again immediate, and we jump, if negative, to memory location 202. So this instruction here will take us from this point to 202, where we go through the process again. So each of these locations refers to an actual point in the RAM. Now let's take a look at relative. Okay, so relative addressing refers to values, refers to memory locations in relation to the start point. Okay, so this start point here could be any point in RAM. Now, let's say it's 200, so we've got the exact same situation as with the absolute. But what is important is that we've got the base register. The base register stores the memory location of the first line of code. So if this was 200, if this loaded into, no, let's change this. Let's say it's 300. So this goes to 300. So this line here is at 300. So the lines of code instructions, each instruction is stored in these 305, 306, 307, 308, 309. Hang on. This here is this one, this one, this one. I followed the lines of the page rather than the lines of the instructions. This is 308, this is 309, and this is 310, 310. Okay, so the value in the base register is going to be this one, 300. So we've got in the base register the number 300. Yes. Okay, so we start it again. So again, this stores 0 in the accumulator. Now at this moment we don't actually need a reference because we're just copying a value into the accumulator. The accumulator is always the accumulator and is always the same place in the CPU or in the processor. Then we have to store that value, and we store that value with the base register, which is 300, plus 10, which is 310, 310. So we store that value in here. Then we load into the accumulator number 42, we output. Then we load the value that is in BR, 300 plus 10, 310, this one, into the accumulator. We increment the accumulator. We store at BR plus 10, 310, the incremented value. So again, we're storing the value 1 in the location 310, and then we compare with the number 5, whatever's in the accumulator, which is currently 1, and we jump, if negative, to the base register plus 2, or that is base register 300 plus 2, which is back to the beginning of the loop. And that's really the difference between absolute and relative addressing in low-level programming languages. I hope that makes sense.